right, in 341 you had to analyze pedigrees. So quickly, let's just review pedigrees. So remember, these are males, these are females. These guys, all the ones in black, have the trait, and these guys do not. Or these women here. This is a guy. So these people would have, but it's dominant. The reason why it's dominant is because, one, there's no carriers. There's none that looks like this. Alright, so there's no carriers, because if it's dominant, you have the disease. You can't just carry it. And you can also see that because there's two recessive people here, they're only going to have kids that are recessive. Alright, there's really no chance of having these. And then you can also see these are not marked as carriers because they have the disease, but they had to be big R, little r, because they passed on two little r's to kid number 7 there. Alright, so that's how you know that's dominant, but that's not the real focus of this one, because we're going to focus on sickle cell, and sickle cell is recessive. So, here's a genetic pedigree for a recessive trait. Alright, and again, you just need to know that these guys are carriers, so they're big R, little r. Big R, little r. And then these guys would be normal, so they're big R, big R. And these guys would be the affected people with the gene, little r, little r. Alright, so then you're going to have to be able to just figure out, okay, if these guys are big R, little r, what are the possibilities, what kind of kids can they have? These guys are big R, little r, and little r, little r. So remember, these guys cannot have any children that are big R, because he can only pass down a little r. So they can only have big R, or little r children. These guys are big R, and big R, little r, so they cannot have, these guys can't have little r children. They can only have big R, little r like that one, or big R because of what this person can pass on. Alright, whereas these people can have all three types. They can have big R, because they can each pass on a big R, little r, little r, little r. Alright, and you should know that, or remember that, from Punnett squares in bio, but we will come back to that. Alright, now for our pedigree here. Alright, so we had, on here we have this one. It's kind of hard to see, but this one person had sickle cell. This one is a carrier, and this one is a normal. Alright, and notice how a normal has 2 bands, carrier has 3, and sickle cell has 1. The reason why carrier has 3 is because a carrier has, remember, this is little r, so here's his little r, they match up right there. He's big R, and then his big R matches up right here. So he has bands at both, because he has both genes. Alright, so now this is pretty easy. You just have to figure out what these are. So Carlos he has 3 bands, so he's a carrier. Eric has 2 bands, so he's big R. Juanita is 3 bands, so she's big R, little r. And then Aaron and Jason are both sickle cell, because they only have 1 band, like the sickle cell. So all you do is compare these bands to these. Alright, and then you would make a pedigree. So Carlos, I'm not going to make the actual pedigree, but Carlos is a guy, and he's a carrier, because I can't remember exactly how they're all related. Eric is a guy, and he would be not filled in. Juanita is a girl, and she would be a carrier. And then Aaron and Jason would both be fully colored in. Alright, so that's what you should have gotten. Plus, Anna's going to be fully colored in, because we already know she has sickle cell. And then you would just make the tree based off of their relationships. Alright, so that's what you had to do. It's basically just take this, you're just comparing the bands, and then making that into a pedigree.